Hi, and welcome to the Intro to iPhone Development Screencast series. I'm your host, Ben Sherman. I work for Chai One in Houston, Texas. In this series, you'll learn about the iPhone platform. You'll learn the capabilities of the device, the Cocoa Touch libraries for user interface design, and of course, writing Objective-C to build cool apps. By the end of this series, you'll have all the tools you need to create your own applications. However, today we're going to answer the question, why build iPhone apps in the first place? First, the iPhone is an amazing device. It has plenty of functionality for you to create interactive, entertaining, and innovative apps. Second, there are 40 million devices out there. That's a lot of people. Each one of them is a potential customer. And third, the App Store is a great distribution model that can get your app onto the market and make a little bit of money. Now don't be fooled. The days of spending a weekend creating a fart app and selling it for 99 cents and retiring a millionaire are long gone. But don't let that discourage you. It's actually not that difficult to create a useful app that lots of people love and make a decent side income doing it. That's what I did with my app, Pocket Tabs. Pocket Tabs is an app to find and save guitar tablature so that it is always handy when you need it. I launched the app in November of 2009, and by Christmas week it was featured in the new and noteworthy section of the iTunes App Store. It took me about 6 months to learn Objective-C and iPhone development and build the whole entire app in my spare time. I'm definitely not rich, but it is certainly nice to be getting a little bit of money every month for something that I really enjoyed building. Let's take a look at why the iPhone is such a compelling device. First off, the screen. The iPhone has a gorgeous display. It has a resolution of 320 by 480 pixels and is covered with touch-sensitive glass. The screen can detect and track 5 distinct touches. This means you can put down 5 fingers on the screen, wiggle them independently, and track them in your application. This gives you lots of opportunities, such as pinch and zoom, swipe gestures, and even 5-finger drawing. It also has a great camera that you can tap into. You can take pictures from within your app, draw on the camera display itself, or even select photos from the iPhoto library on the phone. The iPod Touch does not have a camera, however, so you'll have to plan for this. The iPhone devices all have some form of GPS. Using techniques such as Wi-Fi hotspot tracking, cell tower triangulation, and actual GPS satellites, it can progressively pinpoint the user's location and give directions. You can enable this feature in your own apps, and it will start feeding location data to your app regularly as the location gets more precise. Some companies, such as TomTom, have used this to build sophisticated in-car navigation apps that rival their own manufactured devices. The iPhone also has an accelerometer. An accelerometer is present on all devices, giving you access to tilt data in 3 dimensions. This game, called Topple 2, leverages tilt to allow the user to balance the stacked blocks and try to prevent them from falling. You can also do innovating things like drinking beer. As you tilt the app, the beer pours out as if it were in a real glass. This app, called iHandyLevel, has proved to be very useful to me around my own house. Notice that the precision is to the 10th of a degree, giving you plenty of power for all sorts of scenarios. New to the iPhone 3GS is a compass app, powered by an internal magnetometer. If you had the same reaction I did and said, big deal, then think again. It took me a few weeks to realize the potential that this brings to the device. If you combine the data provided by GPS, accelerometer, and now magnetometer, you can enable some really amazing concepts, sometimes called augmented reality. In this case, the app is using the camera, GPS location, and tilt to determine what the user is looking at. They can then query a backend system and overlay relevant content on top of the real world. This app is called StarMap, and it's really cool. You basically point your iPhone at the sky, and it tells you what constellations you're looking at. This app would have been handy during my last trip to Paris. It shows you the nearest subway entrances and which trains you can find there. The iPhone is also a really capable gaming device. There are over 21,000 games on the App Store today. Many of them leverage the 3D accelerator on the phone, and they do that using one of the industry standard 3D libraries, OpenGL. OpenGL ES is the mobile version of OpenGL. With OpenGL, you can draw polygons or meshes, import 3D models, wrap them with textures, apply all kinds of effects, and move a camera around a 3D world. If you're not afraid of a little matrix math, then definitely check out how to use OpenGL. It's definitely more work than using the standard UI libraries on the phone, but if you're building a 3D game, this is what you'll use. Next, let's talk about the APIs on the phone. You can import the address book framework to access and modify contacts on the device. A recent update to the Facebook application allows you to try to match up your contacts on the phone with your Facebook friends. If a match is found, it'll pull down the profile photo and attach it to the contact, so that when your friend calls you, it'll show up on the picture, which is very handy. MapKit allows you to embed Google Maps inside of your own application and potentially adding overlay content or pinned items on the map. Core Animation is where all the nice effects come from. It is a high-level API which allows you to do complex animations with minimal effort. Animations can really enhance a user experience. Finally, you can access the Media Player framework to play audio and video, including tracks from the user's iTunes library. There are more frameworks available to you, but these should be enough to give you an idea of what's possible. Now is a good time to investigate what you can't do. There's a lot of things you can't do, actually, and the iPhone is a pretty crippled device in some senses. The biggest one, and the one that people find the most frustrating, is you can't run apps in the background. That means your Pandora app, which plays radio that you actually like, can only function if it's in the foreground. The minute you click the home button, the app is forced to quit and the music stops. Jailbroken phones don't have this restriction, but in reality not many people will jailbreak their device, and you can't distribute an app on the App Store that is only meant for jailbroken phones. The main reason for this is battery life, but there are compelling reasons why you'd want to run in the background. Certain functionality can be achieved via push notifications, which basically means you have a server running somewhere that can tell Apple to notify users, either with a badge icon on your app or a message prompting the user to open the app. You also can't access the internals of the phone. You can only have the app dial a number for the user, but your app will be suspended while the actual phone app launches. A similar restriction lies in SMS. You can't send or receive text messages, but you can launch the app with the number pre-filled. Lastly, you can't access any of the system internals. Your app will run in a sandboxed environment with limited access to the operating system itself. So what do I need? Well, first you'll need a Mac. Actually, let me rephrase that. You get to buy a Mac. I'm a recent Mac convert, and I have been so happy with their experience that I now have more Macs than I do PCs. Some of you will not want to spend a lot of money if you just want to tinker. You don't really need a powerhouse machine to build apps, so you might consider a Mac Mini. The Mac Mini runs about $500 retail, but you can usually find used ones for $300 to $400 on Craigslist or eBay. Just make sure you get an Intel version. You'll need your own monitor, keyboard, and mouse if you go this route. Next up, you'll need Xcode, and it's free. Xcode is the IDE, the Integrated Development Environment, that you can use to write Objective-C code. Xcode can be installed on your Mac installation DVD, or alternatively bundled with the iPhone SDK, which you'll have to download. It's about 1.6 gigabytes, so plan ahead. The SDK itself is free, and you can use that to build apps. You'll be limited to running them in the simulator, however, and if you want to deploy them to an actual device, then you'll need to pay $99. This will go to the iPhone Developer Program. It gives you access to a number of resources and allows you to generate certificates for deploying to a device. You'll also be able to submit your app to the App Store with this program. So now you understand what the device can and can't do, what you'll need to get started. Next, let's dive into the apps themselves. I found it to be extremely helpful to dissect existing apps to decompose them into their logical UI elements. That will help you when you're brainstorming your own apps. It's also a good idea to understand the UI conventions that are set in place, because if you use an element in an incorrect manner, Apple may reject your application. Be sure to read Apple's Human Interface Guidelines as well for tips on how to build your UI. This is the Contacts application. At the top, we see a very common element. The grayish blue bar is called a navigation bar. It is controlled by a UI navigation controller. It has a title, a back button, and an optional button on the right. Next, the main body of this view is a UI table view. And the UI table view is one of the most common, it is the most common control you'll see. You might not always recognize it, and that's because it's highly customizable. So this red box is the UI table view, and inside of it are a bunch of UI table view cells. The cell is the main component of a table. A UI table view only ever has one cell per row. This is different than most desktop and web platforms, where a table consists of rows and columns. On the iPhone, a cell is just one row. Now you have a lot of flexibility inside of the UI table view cell to customize how it looks as well. If you select this row, it highlights and slides a new view in from the right. This screen is also a UI table view, but the style of this one is UI table view style grouped. And that's why we have the rounded rectangles and the pinstriped background. We can see at the top that it has a custom header, where you see the Add Photo box. And each one of the rounded rectangles is a separate section. Some sections only have one row, and others have multiple rows. Here you can see we have many different sections to logically group and separate cells. We also saw this on the first screen, where each contact was grouped by a letter. If you use UI table view style plain, it looks like the first screen, whereas UI table view style grouped will give you the pinstripe background and rounded rectangles. If we go back to the root view and click on the search button, it darkens the rest of the view and brings up a virtual keyboard. And that's one of the ways you can utilize more of the display by only having a keyboard open when the user is actually typing. You cannot customize this keyboard, but you can choose between a few different templates. There are templates for phone numbers, email addresses, and URLs. This is the Settings app, and again, it is also a UI table view based application. It only has one section. Notice that there are images on the left of each cell. Now let's take a look at photos. Again, we have a UI table view. Noticing a pattern? At the top, we have a navigation bar, but this time it is translucent. You can also set a tint color to the navigation bar. The status bar is also translucent and black. Also notice that they've used a custom UI image view on each cell. UI table view cell supports this out of the box. If you select a library, you'll see your list of photos. Now you might not know at first glance, but this is also a UI table view based screen. Each row of 4 photos is a single UI table view cell. This one is clearly heavily customized, but it shows you the flexibility of the table views. Now take a look at the bottom. We have another element called a UI toolbar. These typically go on the bottom and provide contextual actions that act on the current view. They shouldn't be used for navigation. Notice that when we scroll the photos slide behind the translucent elements. The way this nice scrolling works is through the functionality in UI scroll view. In fact, UI table view inherits from the UI scroll view, which gains all of its functionality. Here is an example of UI scroll view. It's just an image, but you can pinch and zoom this image. So you put 2 fingers down, spread them apart, and it zooms in. What it does is take the distance between your 2 fingers when you start, and then the distance between your fingers when you lift, and that's how much it's going to scale the image. The UI scroll view is also smart enough to allow you to provide multiple resolutions and swap them out dynamically on demand. So when a user zooms in, they get a high resolution version, and when they zoom out, they get a lower resolution version. This conserves memory, but also allows you to do things like Google Maps, where the size of the image is way too large to load on the phone all at once, so it can actually dynamically load images that are about to be displayed. You can put your finger down and pan around inside of a UI scroll view when it's zoomed in and see the content. Most applications support rotation, and that is because most of the controls support auto rotation. That means if you tell the framework that you support auto rotation for a given orientation, your controls will automatically animate to the new orientation and size. So your navigation bar will automatically stretch to the new width. You could alternatively provide a different view for rotation, and the iPod app does this, When you rotate it, it shows the cover flow screen for you to swipe through albums. And finally, these are some other UI elements that you can use. The one on top is a UI segmented control. This is meant for a single selection only. It is used anywhere you'd typically use a radio button. The UI button is fairly obvious. It handles taps. UI switch is a simple toggle useful in areas where you'd normally use a checkbox. And UI slider allows you to slide up and down choosing a value. This is useful for volume or speed controls. The next one is a UI progress view, which is useful for displaying progress, loading some data, or downloading a file. And lastly, we have a UI date picker. This is a specific case of UI picker view that is pre-built to select dates.
Okay, so let's take a look and see what iPhone development is really like. I'm going to launch Xcode, which is the IDE that you'll use to build iPhone applications. When you launch Xcode, you're greeted with this window to create a new project. Now notice there's a few different templates. You can create iPhone applications here or Mac applications with Xcode. We're going to choose iPhone application, and on the right there's these different project templates that we can start with. So if we're building one of these types of projects, it might be handy to start with a working application that shows the basic structure. But with any wizard, you should be wary of code that you didn't create. And I would recommend starting with one of these two bottom ones, which are more bare bones, rather than starting with one of these, which have a lot of stuff wired up for you. And the reason is, when you want to change something, if you didn't write that code, it's likely that you don't understand it. And we should always shy away from code that we don't understand and instead build it ourselves. So I'm going to select view-based application, which is just going to give us one simple view with nothing on it. And I'm going to name it Hello TechPub. So this is the Xcode IDE. It's similar to Visual Studio or Eclipse if you're familiar with those platforms. Over here on the left we have the Groups and Files pane. This is our Xcode project. These are different groups which we can use to logically organize our classes and files. And notice the view on the top pane here shows us the files within that group. So these are not folders, they're just a way of logically grouping our classes so that we can make sense of it in large projects. If we were to look at this on disk, it would just be one big list of files. And if we select a code file, then we see the code here at the bottom. Okay, so notice that it created a ton of stuff for us. So let's just build and run and see what we get. Notice that we get an iPhone simulator that comes up. It looks just like an iPhone, and it's going to launch our application. And voila, we have a plain, flat, gray view. So for now, I want you to ignore most of these files and just understand that that's some of the stuff that you get as part of your project template. The three files I want you to focus on for now are these three here: Hello TechPub View Controller.h, Hello TechPub View Controller.m, and Hello TechPub View Controller.xib. I'll explain these each in detail. This is a header file, which basically contains all of the instance variables and method signatures that the class, our view controller class, is going to implement. The .m file is the implementation file, which obviously contains the implementations of each of these files. Now the language that we're using is Objective-C, which has its roots in C. So if you've ever done any C or C++ development, this will probably look familiar. Third, we have the Hello TechPub View Controller.xib. This is a nib file, which stands for Next Step Interface Builder. And in past versions of Xcode, the extension has been NIB. But in more recent versions, they have an XML-based version, and so they rename it XIB. But everybody still calls them nibs. And the nib is an interesting file. If you're familiar with Visual Studio, you probably opened up a design surface at one point in your career and dragged and dropped a few controls. And that actually modifies a designer file, which the where the IDE is actually writing the code for you to lay out your visual elements. And that's exactly what this file is doing, except they accomplish it in a little bit of a different manner. So let's open that up and see what it looks like. So we're now in Interface Builder, which is a separate application. So when we launch a nib, it'll open up that nib in Interface Builder. This is the main Interface Builder window, and we're a little cramped for space here in this recording window, but I'll go over each of these concepts in detail. So over here we have the library, which basically is like a toolbox, which contains a bunch of UI elements that we can drag and drop onto our view. Some of them are visual, like labels and buttons and sliders. Some of them are non-visual, like other controllers. Here's our design surface. And over here on the right, we have our inspector. And there's 4 tabs at the top that just give us different ways of looking at the different objects. Okay, let's drag a few things onto our view. I'm going to drag a label and a button. Notice how we get these snap lines to help you line it up nice and neat. Okay, if we double click on the button, we can give it some text. And I'm going to resize this label as well so that we can put a larger message in there. And we can set some properties like the color and the size, and I'll center it here. Okay, now I'm going to save it. And that's an important step that some people forget. Make sure you save it, otherwise you're not going to see your changes happen in the simulator. So I'm going to quit Interface Builder and go back into Xcode. Let's run the application again. And this time, it loads up the nib file, which lays out our elements for us. So this can be a compelling alternative than laying out all of your views in code, which is fairly tedious. Obviously, we have no behavior, so nothing's going to happen when we tap the button. So let's do that next. Back into Xcode, I'm going to go into our Hello TechPub ViewController.h file. Now, the language that we're using here is Objective-C, like I mentioned earlier, but don't worry if this looks a little foreign. When I first started, it was foreign to me as well, and I really struggled with understanding the syntax. But after a few tries, it started to become second nature, and by the end of this series, all of this stuff will be second nature to you as well. So I'm going to quickly get rid of those 2 panes there so we can focus on the code. And we can see that our Hello TechPub ViewController inherits from UI ViewController. And in between these 2 curly braces, I could put instance variables. So I'm going to create an instance variable to hold on to our label. And I'll call it button label. Now notice that we put the asterisk here because this is a pointer to a UI label instance. And there's one other thing we have to do here, and we have to basically tell Interface Builder, hey, pay attention to this label, or this variable, so that we can use it in Interface Builder. And to do that, we prefix it with IBOutlet. Now in the compiler, that's actually defined as nothing, but Interface Builder does look at it to determine what to pay attention to. In addition, we want to define a method that will receive the button tap event so that we can update the label. So I'm going to define a method here. Now normally this would be a void method, and we'll give it a name called button tapped. But again, we have to give it a marker so Interface Builder will pay attention to it. So for this, we'll do IBAction. So this is the return type, and if we take a look at IBAction, it's just another alias for void. So again, it tells Interface Builder that, hey, pay attention to me. So I'm going to save this file, and we're going to launch that nib again. And we're going to do what's called making connections. So this might feel a little confusing to you. If you're familiar with Visual Studio, a lot of times these buttons and labels will just be classes and variables within a code behind file. But it works a little bit different in Objective-C. So what we need to do is we need to somehow link our view controller to this label via that instance variable, and this button's tap event to the view controller's method that we just created. So down here at the main Interface Builder window, we have this thing called Files Owner, and the type is Hello TechPub ViewController. So that basically says that this nib file manages Hello TechPub ViewController. Now down here on the bottom we have our view hierarchy. So this is our main view, the label, and our button. So what we're going to do is we're going to drag from Files Owner to the label, and we can do it up here or on the hierarchy below, and we're going to let go. So again, that was Control, click, and drag. And notice that we have an outlet here for that variable that we set. Now if you're trying this at home and you don't see your label there, your instance variable there, then that means you either forgot to add the IB outlet marker in front of it, or it's not marked as UI label. So Interface Builder isn't going to show you the ones that don't match up here. So we're going to click on that and it'll flicker to indicate it made a connection. We're going to do the same thing but in reverse for the button down to Files Owner. I'm going to let go and we get our event here, button tapped. Again, if you don't see that event there, then you probably forgot to mark it as an IB action method. One way to view these connections, and optionally remove them if you make a mistake, is to go over here to this Connections Inspector. So we've got the button selected, and if we go to the Connections Inspector tab, we see all the different events that the button has. And in the Touch Up Inside event, which means the user lifted their finger inside the region of the button, we have that linked to Files Owner button tapped. Now we already know that Files Owner is our view controller. And if we wanted to get rid of this, we could just click the X here. Now if we wanted to wire up one of these other events, like maybe immediately when the touch came down inside the region, then we could drag from this arrow somewhere else for a different method to link up again. Now we're back in Xcode, and if we build, we're going to get an error. A button tapped method in our header file, but we haven't given it any behavior. So let's do that next. I'm going to use that shortcut key Shift Option Command E, which will get rid of those two panes. And another one you might want to remember is Option Command Up Arrow, and that's going to flip between the header file and the implementation file. So here I'm in the implementation file, and we're going to write the body of that method. You see down here, build succeeded, and we're ready to run it. Okay, we see our button, and when we tap it, it updates the label. So again, this is a really simple application, but the goal is to give you an idea of the tools involved and the techniques that we use to build iPhone applications.
So now you know all you need to know to get started. You know what the device is capable of, and what the SDK can and cannot do. Start thinking of applications that you want to build. Try to envision which UI elements you would use and where. I would suggest to start small at first, to something that is actually attainable in a short amount of time. I can't tell you how exciting it is to actually come up with an idea, build it, put it on your phone, and show it to a friend. It's a very rewarding experience. So start thinking about that, and tune into the next episode where we'll build out our first iPhone application. Thanks for watching.